recognizing the graph of a rational function. So first off, say we wanted to graph the function f of x equals 1 over x plus 1. The first thing to note is vertical asymptotes, I'm going to shorthand VA, are places or x values that will create a situation where we're dividing by 0. So x equals -1 would be a vertical asymptote because -1 is what makes x plus 1 equal to 0. Horizontal asymptotes have 3 rules. If the degree of the numerator and the denominator are the same, the numbers out front are the horizontal asymptote. If the degree of the denominator is bigger than the top, you have a horizontal asymptote at 0. If the degree of the numerator is bigger than the degree of the denominator by 1, you have to do long division to get a oblique or slant asymptote. So first off, the degree of the denominator is 1. There's no x in the power, so the denominator has a bigger degree. Therefore, y equals 0 is the horizontal asymptote. Well, what does this look like? We have this vertical asymptote at -1. Our graph actually does something like this. And we have a rational function graphed. Well, what if we're given f of x equals 2x over x squared minus 2x plus 15? Remember that denominator factors to become x minus 5, x plus 3. Excuse me, this should be a -15. Therefore, we have vertical asymptotes at x equals 5 and x equals -3, because if we set this equal to 0, we'll get -3. If we set this equal to 0, we'll get 5. These are the two spots that make this a divide by 0. Horizontal asymptote, well, the degree of the denominator is bigger than the degree of the numerator. Therefore, y equals 0 is the horizontal asymptote. If we graph this function, what does it look like? Well, we have 1, 2, 3, 4, 5, a vertical asymptote at 5, and a vertical asymptote at -3. So we have those two. Then, we need to figure out if we're above or below the x-axis for this type of a look. So, what I like to do is just pick points. If I plug in -4, I get -8 on top. So when x is equal to -4, I get -8 on top. In the denominator, I get a negative number. Therefore, a negative divided by negative is a positive. Excuse me. I get -4, -9, -4, -1 times together makes a positive, right? But negative divided by positive is a negative. Therefore, my graph is like this. If I stick something bigger than 5, say when x is equal to 7, I have a positive in the numerator. If I stick in the denominator, I also get a positive, so therefore I get a positive on this side. And actually what this function does in the middle is if we graphed points, it would look something like this. You'll get more into these graphs if you go on to take 1050, so you'll get more in depth, but this at least introduces you to this idea that we have what are called asymptotes, and asymptotes are lines which our function will get infinite infinitely close to, but never touch. And that's what these are. So these lines are going to get as close as humanly possible, but not actually touch them. Kind of cool.